G'day YouTube. Warbles on a lot here. Those of you who've been paying attention to the channel for any length of time may well remember that about 5 or 7 years ago I acquired a size 2 Trafalgar Cold-Safe, patented in 1918. W.J. Rawlings, Australia. And I had great hopes that this would be the answer to my refrigeration needs. But apart from the fact that you can go nearly mad trying to maintain the correct drip rate, because the drip rate is dependent on the water pressure in the tank above the tap. So the correct setting when you've got a full tank of water is different to the correct setting when you've got half a tank of water, which is different again to when you've got bugger all water. So you have to come and visit the thing and adjust all 8 of its taps. Well, maybe not quite every half hour, but every hour or every 2 hours as a minimum. And then there's the feature that it works on relative humidity. So if you've got a lot of water already dissolved in the air, it's going to be difficult for water to evaporate off the fabric screens on the outside of the metal screens. Metal screens are to keep the insects out, but let air pass through, and the fabric screens get wet by the drip, drip, drip from the top, and the water percolates through and gets collected and reused. But it's supposed to evaporate, and it takes a lot of energy to evaporate water, and the energy comes out of the air, so the warm dry air goes through the wet towel and becomes cold wet air, which then gets blown away by the wind. So this thing needs to be in the shade in a relatively windy area, and you have to have a relatively low relative humidity, like 20 to 30% relative humidity is good. 10 to 20% bushfire fuel bomb territory is absolutely perfect for it, because it can just throw the water into the dry air and lower the temperature of the air going through the cabinet. Great. But 2 years ago, when I really should have changed the curtains on it and all the rest of it, the El Nino finished and the drought ended and the heat waves finished, and we moved into a La Nina, and that means that 68, 72, 78% humidity every day on day on day on day. Cloudy days, fairly cool, very humid air. That thing's not much better than just a tin box in the shade for the past 2 years. And I saw a need in my life for some more efficient form of cooling my food, because that thing, quite frankly, it isn't good enough to keep butter solid. It's no good for keeping cheese. It's no good for keeping vegetables. It's tolerable to keep your beer cooler than the air. If you've got a cycle where it's 10 degrees as your overnight minimum and 20 degrees as your midday maximum, then by about 3 or 4 o'clock inside the Cool-Safe, it'll be about 13 or 14 degrees, which is noticeably better than not having the Cool-Safe or Cold-Safe. But if you've got a drought and a heat wave and 20 degrees as your overnight minimum and 40 degrees as your midday maximum, then you're still looking at 25, 27 degrees for your cheese by 3 o'clock in the afternoon. You know, that's not going to last very long. Vegetables aren't going to last very long. So in this application in a forest on top of the Great Dividing Range, it's better than nothing, but not much better than nothing. And in a La Nina, it's not even so much better than nothing that it's been worth my while to put new curtains on it. So I haven't. And then, as she was preparing to move up here, get away from the rent syndrome, my daughter was given this device with a window in the door and a metallic element for the Peltier device on which it runs, 240 volt power cord. It has a fan air inlet It'll run on 240, it'll run on 12, it'll run on AC or DC. It'll either sit off, it'll cool things down, or it'll heat things up. And I'd heard about these things and I thought, oh dear, what a tragic idea. 65 watts. And me being me, yeah, I can show you the test results. And yeah, if you got the heater element on, it's 4.9 amps. And if you got the cool element on, it's minus 6 amps. And half a degree per minute. 15 degrees of cooling in the whole box in half an hour. 6 times 24, 144 amp hours a day. 10 watts of 240 volt DC current per amp hour. So we're talking about 2 horsepower hours per day. No wonder these things are called battery killers. So I informed my daughter that when she gets her yurt erected on the pad, and if she connects this thing via an inverter onto this 225 amp hour 12 volt deep cycle battery setup, then even when she has a solar panel approximately the size of this one, because this is a 170 watt panel and I'm currently still waiting on delivery of 2 80 watt panels, so she'll have 160 watts to feed those with. But even when that has been replaced with something like that, it'll only put out maybe 80 amp hours on a good day. So this will take 48 hours before it completely, absolutely flattens and kills $500 worth of batteries. And as I said to her, I will supply you with a set of batteries, an inverter, a charge controller, and enough panels to charge the batteries to enable you to run pretty much without a generator and use about 25 amp hours a day, which is what I run my hut on. And if you kill the batteries, then you'll just have to replace them out of your pocket, because you know that's a bootstrap system. That's the smallest solar power system that you really need to be living in the bush on a very modest means. If you want extra fripperies and frills, well, this system over here, a completely modular unit, it was bought with the intention that that's what I'm going to charge the electric bicycle with, because I have 4 of these and I have 2 of these, and these suck about 10 amps to make the 100 watts with which they charge these. And 225 amp hours worth of 12 volt storage can withstand a 20 amp drain for an hour as its daily cycle. It's working them hard, but it can do it, and then get topped up, refilled at 10 amps. So to run 2 bicycle battery chargers and charge 2 bicycles at once, all I require is a sunny day. And the batteries can be charging or powering one battery charger, and the solar panel can be powering the other battery charger. So that was my designed setup. At the moment, the bicycle charging battery and charge controller and panel, as you can see, are connected to wiring going into the house. Because in here is a thing they call a brass monkey, a 35 litre variety of a brass monkey, which is a dual zone 12 volt fridge. Now it claims that the battery outside is at 12.7 volts. The battery outside is actually at about 13.5 volts. It has LED lights, it has a small zone, it has a large zone, and it means I can keep half an avocado and it's still worth using 2 days after I cut it and been in the fridge for a week. I can keep me butter, I can keep me eggs, chocolate, vegetables, lemon, lime and bitters, tonic water. Should be a ginger beer in there as well. Yes. The light goes out when the door gets shut. When I bought it, oh yes, look at that sneaky preview. There is the collapsible trailer to go behind my e-bike. However, back to the topic at the hand. When I bought it, it was after very close cogitation, looking at the figures on the box. Average power consumption, 280 watt hours per day. Well, that's pretty much what my hut used for the lights. 60 watt compressor. Yeah. So I had the idea when I brought it home in its box that I would be running the thing on 240 volts of alternating current electricities with the supplied AC DC adapter, which I plan to feed with the inverter over here drawing on 450 amp hours of storage. Currently using about 0.8 of an amp hour to charge my mobile phone. And I thought, okay, I'll have to have this inverter running 24 hours a day so that it's actually operating, providing current. So I'll just leave the bedside radio's transformer plugged in and switched on. And then I thought the fridge would be able to draw power from this inverter as and when the fridge needed it, because that's amps going in, that's amps coming out. When I run, for example, a mobile phone charger, the amount of current going into the phone is reflected by the amount of current drawn into the inverter. If I'm charging drill batteries, the amount of current going into the drill's battery charger, its transformer, is reflected by the amount of current going through this amp meter from the batteries to the inverter. However, when I tried to run the Brass Monkey fridge on its AC to DC adapter so that it could run off the tower of power as an integrated normal part of my household electricity system, tower of power to the electric pyramid, conversion after storage, and then across to the hut. See, it claims that it's 10.9 and it'll actually be about 13.2 volts. I don't know whether it's line drop or whether it's just a crazy ass sensor over there. But anyway, I have assured myself that the voltage is nothing like what it alleges it is on that display. So, being me, yes, not only do I document, but I store the documentation where I'm not going to forget it, eh? So we have the Brass Monkey, which set me back $449 because of $50 GST. And we have a test of that Maitre D thingamummy jig. And then we have the first test of this thing, and the bloody thing uses 6 amps continuously, no matter what the fridge is doing. 6 amps is the nature of the draw from the batteries to the inverter to feed the AC to DC power adapter required to put 12 volts of the direct current into the Brass Monkey. 6 amps for 24 hours, 144 amp hours a day, which is 2 horsepower hours, which means that any poor, silly, trusting consumer who believes all this stuff and thinks that it's going to do just as well on 240 volts AC as it does on 12 volts DC, they are in for a rude, heavy shock, a pain in the arse, so to speak. Because if you bring your Brass Monkey home and try to run it on your off-grid solar electric pyramid through the supplied 240 to 12 volt adapter, instead of 24 amp hours a day, it's going to use 144 amp hours a day. And you will kill your batteries, just exactly as if it was a battery-killing Peltier-Effect cool box, hot box abortion of a thing. And that's pretty much all, because this is designed as a camping fridge. It's supposed to run on 12 volts, either from your car, from a 12 volt battery system like I've got set up, or you can put a optional lithium ion battery into it, either a 7 amp hour or a 15 amp hour, 15 amp hours is not enough for your 22 amp hours per day that it's going to actually use. So those are really only good for a half-day fishing expedition away from the car sort of thing. That's not figuring the extra power that you have to draw out of the batteries to run that transformer, which takes half an amp, so that's 12 amp hours per day on top of your 144 that the fridge's power system is going to suck. Therefore, to make the $450 35 litre Brass Monkey camping fridge live up to its 1/3 of a horsepower hour per day, all it takes is $500 worth of lead acid golf cart batteries, about $130 worth of 30 amp charger, and a 100 watt solar panel. Not quite as big as that one, but I've had such great success at this thing running the fridge, even on 4 cloudy, rainy days in succession, without the battery voltage going perturbingly low, like not below 12.8 volts actual, while supplying 4.6 amps for a maximum of about 15 minutes. So all up, you're really looking at about $750 worth of solar panel, charge controller and batteries in order to run a 35 litre Brass Monkey fridge, which is otherwise quite friggin' delightful. And of course, I have observed and documented the Brass Monkey's power consumption. For the first 4 or 5 days that I was using it, until I come to the conclusion that yes, that panel and those batteries can run this fridge without harming the batteries and without the fridge running out of power. So that, at the moment, is about what I know. There you go, got to push hard to get it to come down and lock in. That's about what I know about off-grid refrigeration. The Evaporative Cold-Safe, a 12-volt battery-killing Peltier-Effect device, which is absolutely not worth having whether you've connected it directly to your battery or via a 240-volt inverter. And the proper Fuller compressor fridge with a DC neodymium high-efficiency electric motor and rinky-dink circuitry that will, in fact, perform as advertised, but only when it's fed pure direct current from its own dedicated batteries and its own dedicated solar panel with its own dedicated battery charge controller. If you want your $450 35 litre Brass Monkey to live up to your expectations, just give it $750 worth of its own dedicated solar electric standalone setup, and together you and your refrigerator will be as happy as the proverbial pigs in mud.